So now let's talk about some basic curves in the polar coordinates. These curves are so basic that we'll just expect you to kind of know them. So first of all, well, let's look at r equals 2. So think about what you're saying. You're saying that there's a fixed radius of 2 and that theta could be anything because there's no theta in the problem. Oop, anything. Well, okay, I go out to 1, 2, there's 2, and I let theta be anything, means I am talking about a circle. This is what r equals 2 look like. All right, so it's a circle of radius 2 with the center at the pole. As a matter of fact, r equals any constant will look like that. Just for fun, I graphed it in Desmos for you to see. So if I press play on this, so I'm letting r be equal to a. And now you know what I'm doing there. I'm doing x comma y, right? R cosine theta, r sine theta. So I just wanted you to be able to see it graphing it, right? So if I let this go, it's building the circle. See? Oh, I'm going to make it go only forwards. There we go. So r is equal to any constant will just be this circle. And if I make my constant change, like in my case, my constant was 2, but if I make it go to, well, that's too big, 3, there you go. 4, there you can see it, right? It's a circle. So r is equal to a constant is a circle. The rest of the stuff is just fun so I can graph it. That's all I'm doing there, right? Okay, so let me turn off that one. Let's go back. Theta equals pi over 3. Okay, so you fixed your angle with the positive x-axis, or its positive polar axis, right? And it's pi over 3. But r can be anything. So I'm on the pi over 3 angle, but r could be anything, including r could be negative. So r is positive is up here, r is negative is down there. So that's theta equals pi over 3. It's a line, it's a diagonal line through the origin or the pole, right? All right, so far this is not seeming too bad, right? Now there's one other basic type that we want to talk about, which is a circle. But the circle will be in polar coordinates. Now, a circle with the center at the origin is pretty easy, right? So that's no problem because it's just r equals whatever. No problem. But then what about if it's not centered at the origin? So consider this polar equation, which is r is equal to 10 cosine theta plus 24 sine theta. This is what it looks like. I can prove it because I graphed it in Desmos, and here it is, right there, right? So 10 cosine theta plus 24 sine theta. It obviously has a center, right? Hello, center, which is that point, and it has a radius. And what we want to know is what's the rectangular form of that circle, right? How can I make that circle into x and y coordinates rather than r and theta coordinates? Although obviously r and theta is very nice for this. Okay, so we're going to use a little bit of, well, mathematical trickery. So I want to remind myself that r is that's lovely, but r squared would be equal to x squared plus y squared, which would be equal to, now remember, all of this is r, so it's equal to r times r, which is equal to 10 cosine theta plus 24 sine theta, there's an r, see that, times r. Aren't I tricky? Right? So I'm taking this r and I'm multiplying it by r. I can do that. So that means that that's equal to, or x squared plus y squared, excuse me, is equal to 10 r cosine theta, oh, that sounds interesting, plus 24 r sine theta. Why is that intriguing? Well, because r cosine theta should be setting off a little bell in your head. That's x. And r sine theta is y. So I'm really saying x squared plus y squared equals 10x plus 24y. Now, technically, that is an equation. It's an implicit equation. So it's not solved explicitly or anything. And it's kind of yucky, and it's not in the form that we're used to for circles. So this is lovely, but it's not really going to help. So what we're going to do is bring these pieces over. So I'm going to make it x squared plus, oh, sorry, minus 10x, because I'm going to put the two x's together, plus y squared minus 24y equals 0. And are you thinking what I'm thinking? Because I'm thinking we should complete the square. So let me do that. So if I say x squared minus, take 10 divided by 2 and square it, that would be 5 squared. But of course, if I do it to that side, oh, let me take this piece, divide it in 2, and then square it. So it's like that. But if I do it there, then I'm going to have to do it on the other side. Let me go here and say 12 divided by, or excuse me, negative 24 divided by 2 is 12, 12 squared. So 12 squared right here. And of course, if I add it to the left, I have to add it to the right. So I'm completing the square. This bit right here becomes x minus 5 squared plus y minus 12 squared, right? I'm completing the square. Which is equal to, that's 144 plus 25, which is 169. Lovely. And that should look very familiar to you. Yes? Because we've learned this from pre-calculus. This is h, this is k, and this is r squared. This is a circle of radius 13, because 13 squared makes 169, with a center at 5, comma 12. It's HK. Now does it look familiar? Yeah, that's the general form for a circle in rectangular coordinates. Okay, so we've learned a lesson, which is that if we have a circle in polar coordinates, there's two ways we can go. One, we can just do r equals theta. That's really basic. It's just a circle of radius, absolute value of a, right? Because a could be positive or negative. It doesn't make any difference. And it's centered at the origin. Simple as that. Really easy. That's this circle right here. R is equal to a. No trouble. And then if you have r is equal to 2a cosine theta plus 2b sine theta, it describes a circle of radius equal to the square root of a squared plus b squared, centered at ab. Now think about that for just a second. In our example up here, 2a, right? It says 2a cosine theta. See that? So look here. 2 times 5 gets you 10, and that's how we complete the square, because we take 10 divided by 2 and it makes 5 and we square it. Huh? And then 2b, right, is right here. That's 2 times 12. Oh, I should have done that in pink. Sorry, because I did it in pink down below. So 2 times 12, and that's why down here when I completed the square, I took 24 divided by 2 and made 12, right? So it does fit, right? 5 and 12 are our center, and then the square root of 5 squared plus 12 squared. So 5 squared plus 12 squared made 169. Square root of 169, I'll just write it over here, is 13. And that's how a circle works in the polar coordinate system, right? So it gets you the center, A comma B, which in our case was 5, 12, and it gets you a radius equal to the square root of A squared plus B squared, which in our case was 13. And I can show you that's exactly how I graphed it. So there's the black, this red circle is in the polar coordinate system. So I typed it r equals 10 cosine theta, and the Desmos knows that when you type r equals and have theta, it knows it's a polar graph. So let me show you the rectangular form of that circle. There it is. So if I made this part go away, look at that. Rectangular, polar, rectangular, polar. It all is correct, and it all is the same thing.